This video is about sound. Sound is probably the most common longitudinal wave that we will mess around with. What we end up with is something like this. We have air particles and then we introduce a sound. What happens is some of these air particles will move this direction, but then they'll bounce back. So we're going to have, for a moment, these particles moving to the side. But then they're going to relax and kind of go back. But because these have moved to the side, that's going to move these. To the side. While those move to that side, these blue ones have moved back. And even though this is starting to look more like a playbook than anything else, that leaves us with something like this a moment later. And where our blue particles have moved back, we now have this region where our red particles are bunched up, so we get this pulse. If I were to graph this, maybe call this number of particles, what I would see is a relatively steady number of particles throughout for most of the way. But I've got this region where the blues moved back and kind of evacuated. So I will have these reds. I've got this region where the reds are bigger. And then I've got a region where maybe there's a bit of a dip because of the ones that are missing. I have a sound pulse. This pulse will travel down the line, so then my sound pulse becomes something that looks a whole lot more like a transverse wave like I'm used to. In the end, sound is a pressure wave, a longitudinal wave, and we get something that we can measure if we look at an air displacement or graphing, these sorts of things. Sound has, because of this, because we have a pulse, we could plot this, and if we keep our sound moving, we're going to eventually set up a pattern like this. We can, again, if this is position, make a measurement of wavelength. We can definitely get an amplitude out of this. Or if this is instead time, then we can make a measurement of the period of the wave and even find a frequency by taking a reciprocal. There are a couple of things that are helpful here. One, mathematically, this behaves exactly the same way as what you were doing with transverse waves, so that's convenient. Two, sound waves can be recorded, right? You can hear sound waves. When you record your own voice, nobody really likes to listen to recordings of their own voice, and it's because your voice sounds bad, right? I mean, your voice sounds not the way that you hear it when you speak. We have been recording sound for a long time, and different things that we have done for long enough we keep improving on. So why would those recordings sound so far off? It turns out they're not off. We get a wave speed here that in air is going to be something like 340 meters per second. I've seen numbers between 338, 343, somewhere in there, to two significant figures. 340 meters per second is actually a really good approximation. So this is the speed of sound in air. When you are speaking, you expect that that sound is moving through air, and it does. So when I speak to someone, they hear my voice as that sound wave travels through the air. When they speak to me, I hear their voice because the sound wave travels from their mouth through the air to my ear. When I hear myself speak, I don't have that same thing going on. Yes, there is some amount of the sound that travels through the air and comes to my ear, but more of that sound travels actually through the bone in my skull. So it'll travel through my jawbone, through bone, into my ear. If it's traveling through bone and sound is a compression wave is going to travel faster. A longitudinal wave is going to travel faster in a denser medium. So I get a higher speed of sound traveling through bone. Because I have a higher speed of sound, the pitch comes out differently also. So really what ends up happening is that I hear my own voice as lower than someone else would hear my voice. Which means the way that you sound in recordings is actually the way that everyone else hears you. It's just different than the way that you hear you. That's kind of an intro to sound. The next couple lessons after this will deal with what we can do with sound, intensity, volume, things like that. But for right now, that's it.